Next point, effect of feedback on sensitivity. Now, what is the effect of feedback on sensitivity? Let us first see what is actually sensitivity. Sensitivity is the parameter which is a parameter of a plant or process which is under one or more than one, which is under control, which are under the control of the whole system. In that, some external disturbances or other factors, if they are incorporated in the system and they start to disturb the different control parameters with getting some different unwanted values. So that if that happens very easily, that means we can say those parameters are quite sensitive to those external factors and external disturbances. And if it does not happen, it can say that the particular parameter which is under control is not very sensitive to the external disturbances. So this is the way of sensitivity. So for good purpose, some parameters may depend on some external factors. For the benefit of the system, we can say that sensitivity is good for that case. But if it is not beneficial for the control of certain parameters, it may be called that the sensitivity should be poor. Now, effect of feedback on sensitivity, we can say that the sensitivity of the overall gain of the negative closed loop system, control system, that is CS by RS, to the variation of open loop gain G can be defined as this. So this is the mathematical analysis from which we can derive the conclusion that how much feedback affects the sensitivity. So this is the mathematical definition of sensitivity. T means it is CS by RS, C by R, that is T. That means the overall gain of the control system is denoted by T. S is the sensitivity parameter and G is the reference. That means T is varied with respect to G. That means G is the reference with respect to which the variation of the overall gain. So gain in the forward path, based on which the overall gain, how much it is sensitive, is measured via this parameter STG. S of T with respect to G. And that formula is del T by T divided by del G by G. That means del T by T means what? Percentage change in T divided by percentage change in G, where del T is the incremental change in T due to incremental change in G. So therefore, del means a small increment, small change, and T and G is the total overall transfer function is T and the forward path transfer function is G. That means if forward path transfer function is varied, we need to check how much it affects the gain of the overall transfer function in terms of sensitivity of the system. So this is the whole idea. Now, this is the mathematical analysis of this sensitivity concept. Rewriting this above equation, just remanipulate this equation in this form. Del T by T divided by del G by G can be written as del T by del G into G by T. So now this is equation number 1, first equation we have got. Now, if we partially differentiate this equation, why partial differentiation? Because there are multiple parameters dependent on S. So therefore, partial differentiation is useful. For partially differentiating this expression G by 1 plus GH, the overall transfer function which is T, with respect to G on both sides, because the base reference is G. Based on G, we are assessing how much effect of changes in G, how much it affects the changes in T. So therefore, both sides we get del T by del G. We are calculating this term del T by del G by partial differentiation of this expression. That is del T by del G is del G of G by 1 plus GH. We have taken this term inside this and partially differentiating with respect to G. Calculation is shown over here. this is finally it is coming 1 by 1 plus gh. It is just little bit hiding, so it is written as 1 by 1 plus gh whole square. So this is the first derivation of del T by del G.